So today we are going to discuss about inverse Laplace transformation. You know that Laplace transformation of any function f of t that will give us an algebraic function capital F is. So here inside the Laplace operator we have the input f of t, that is a time variable function, and we are getting finally the output as an algebraic function. So time variable is converted or transformed to another new variable that is denoted commonly as s. So this is the main notation of Laplace transformation, and which is one improper integral that converges, and the improper integral is integration from 0 to infinity e to the power minus st f of t dt. So this is the continuation of previous consultation. In previous consultation I have discussed what is Laplace transformation, how to deal with the formulas and with the properties of Laplace transformation, and here we are going to discuss about inverse Laplace transformation. So if Laplace transformation of f of t is capital Fs, then inverse Laplace transformation of this part, that is capital F, will be the main function. So by using Laplace transformation, try to understand, we can convert the main function to an algebraic function. Now suppose we have the algebraic function, so what will be the process to get back to the main function? Actually this is called the inverse Laplace transformation. Okay, so the relationship between Laplace and inverse Laplace transformation is this one. This is the notation for Laplace transformation, and the second one is for inverse Laplace transformation. So let me recall all the formulas whatever we have learned yesterday. Formulas for Laplace transformation. So in Laplace transformation we have seen that Laplace transformation of any constant is constant by s. Laplace transformation of t power n is n factorial s power n plus 1. I have given you the formulas, okay, but we are just recalling the formulas because somehow we have to understand what is inverse Laplace transformation. But inverse Laplace transformation is based on the Laplace transformation formulas. Okay, so these are our prerequisite. Laplace transformation of e power at, that is 1 over s minus a. We can see 1 over s minus a. Laplace transformation of cosine at, that is s over, okay, let me use here k. Laplace transformation of cosine kt. So s over s squared plus k squared. Laplace transformation of sine kt, that is equal to k over s squared plus k squared. So these are the formulas, whatever we have learned yesterday. And also we have the hyperbolic sine formula and hyperbolic cosine formula. So at the same time, we have learned yesterday the three properties of Laplace transformation. Properties. The first property is linearity property. That means Laplace transformation allows us to separate the summation terms or subtraction terms, and also we can pull out the constant before the Laplace transformation Laplace operator. So b g of t. I am just recalling the previous lecture, okay, so that you can relate whatever we have learned yesterday. So what we can do here, we can pull out the constant, and we can also separate the function. So plus b Laplace transformation of gt. So this is the linearity property. We have learned another property which is called shifting or translation property. The property is, we know that Laplace transformation of f of t is f of s. If this is true, then what if we have Laplace transformation of e power at f of t? So you know all the steps how to solve this type of problems by using shifting or translation property. It will be directly f of s minus a. Wherever we have s, we need to replace s by s minus a. So this is the second property, that is called shifting or translation property. We have another property. The property is multiplication by t power n. You can have a look here. The property is given in this PDF file. The property says that if Laplace transformation of f of t is f of s, then what if we have t power n f of t? That will be negative 1 power n, nth derivative in terms of s variable of Laplace transformation of f of t. So those who were present in my last consultation, you know, we have discussed these topics there. And now our target is to have a look on inverse Laplace transformation and how to deal with the inverse Laplace transformation problems. So first of all, let's have a look on the formulas. Inverse Laplace transformation formulae. So we know that Laplace transformation of constant is constant by s. So if we are coming from the reverse position, that means we are using inverse Laplace transformation, then what will be the inverse Laplace of c by s? It will be c. That is here. Laplace transformation says that Laplace transformation of t power n is n factorial by s power n plus 1. Suppose we have n factorial by s plus 1, s power n plus 1 in our given question. So what will be the inverse Laplace transformation, or what will be the main function? The main function is t power n. So the formulas are here. Laplace transformation of e power at is 1 over s negative a. Suppose we have 1 over s negative a and we want inverse Laplace transformation to be applied. So what will be the result? The result will be e power at. So can you relate Laplace and inverse Laplace transformation? Any confusion here?
No, sir.
Okay.
No, sir.
So let me go to the advanced level. So Laplace transformation of constant is constant over S. Similarly, inverse Laplace transformation of constant over S is constant. Try to relate. Laplace transformation of t power n is in factorial over s power n plus 1. So if we want to apply inverse Laplace transformation on n factorial s power n plus 1, that will be t power n. Laplace transformation of e power at is 1 over s negative a. So inverse Laplace transformation of 1 over s negative a is actually e power at. Laplace transformation of cosine kt, that is equal to s over s squared plus k squared. So inverse Laplace transformation of s over s squared plus k squared, that will be actually the main function cosine kt. Similarly, Laplace transformation of sine kt, that is equal to k over s squared plus a squared. So the inverse Laplace transformation of k over s squared plus k squared, that will be sine kt. So in short, we can summarize that if we have Laplace transformation of f of t, we will get f of s, and inverse Laplace transformation of f of s, that will be the main function f of t. All these are the main function f of t with time variable. So whenever we have the algebraic function with s variable given, then somehow it will be complicated to get back to the main function. We have still the formulas, but somehow you have to be very tricky about in dealing with inverse Laplace transformation. So let's try to have a look on the properties of inverse Laplace transformation also, then we can move to the problems. So have a look on the properties of Laplace transformation. Laplace transformation has actually three properties. Property 1 is the linearity property, property 2 is the shifting property, and property 3 is the multiplication by t power n property. But inverse Laplace transformation actually has two properties. The properties are only the first and second one, linearity property and the shifting property. But in inverse Laplace transformation, you will not get this type of properties. Okay? So let's write down the linearity property and shifting or translation property for inverse Laplace transformation. If you are getting confused, you can go through the previous consultation video. Then you can relate whatever I am trying to say. So let's write down the properties of inverse Laplace transformation. So here the first property is linearity property again. So in linearity property, you will see that suppose we have inverse Laplace transformation of f of s plus, let's say, g of s with a constant a and b. A f of s plus b g of s. Then what we can do? Inverse Laplace transformation of a f of s plus inverse Laplace transformation of b g of s. We can separate the summation terms or subtraction terms. Maybe we may have negative also. So since a and b are constants, so we can also write a and b before the inverse Laplace operator. So b inverse Laplace of g of s. And now please try to tell me the final result. So inverse Laplace transformation of capital F S. What will be the result here? Here it will be f of t, right?
Yes, sir.
And plus b Laplace transformation of capital G S. What will be this one? It will be small g. Okay. So this is called the linearity property, because Laplace transformation of capital F is small f. Inverse Laplace transformation of capital F is small f. Inverse Laplace transformation of capital G is small g. So this is called the linearity property. Let's have a look on the second property, that is the shifting property. The property is just same as the property you have learned in Laplace transformation, but in reverse process. So in shifting property, have a look on the previous property, whatever you have learned in inverse in Laplace transformation. The property says that if Laplace transformation of f of t is f of s, then Laplace transformation of e power at f of t is f of s minus a. Now you have this one, and you have to get back to the previous part. So let's write down. The property is inverse Laplace of f of s is f of t. If this is true, then what will be the case for inverse Laplace transformation of f of s negative a? It will be e power at f of t. Is it clear?
Yes, sir.
So
Yes, sir.
thank you. So inverse Laplace transformation has actually two properties. Laplace transformation has three properties. And whatever PDF I have given to all of you, you will see that I have mentioned one note here, that is sometimes the method of partial fraction is helpful while evaluating inverse Laplace transformation. So we have to also recall what is partial fraction. Okay, so partial fraction is a process by which we can split up the combined terms. So now we are ready to solve the inverse Laplace transformation problems. We have all the formulas in our hand, and also we have the two properties. So let's solve some problems from inverse Laplace transformation. We are starting from the easier ones, and then gradually we'll move to the complicated problems. So for inverse Laplace transformation, you can go through the problems from section 7.2 from this book, differential equation, Dennis Chill. So all the formulas are here also. We can you can see inverse Laplace of 1 over s to the power 5 is directly solved to 1 over 24 t to the power 4. So whatever process I am trying to discuss here, that will not somehow match to the BUX video, because in BUX lecture the inverse Laplace transformation problems have been solved by using Bromwich integral. This is a technique, but since your time is short, only you have 2 days left before your final exam, so I think you can take the help from this book. Okay, and this book deals with the formulas whatever I have given here. That will be easier for you. Is it okay?
Yes, sir.
Yes, sir.
So now we will understand if we try to solve some problems. So I have mentioned to you earlier that it is easier to solve Laplace transformation problems, but it will be quite complicated. It will be difficult if we come from the reverse process. That means if we are using inverse Laplace transformation, somehow there will be problems we may have to face. But let's hope for the best. We can solve any problems because we have the Laplace transformation and inverse Laplace transformation idea, and also we know the formulas and properties. So let's start with one problem. So let me think about our problem. Suppose we have to evaluate, let's say, inverse Laplace transformation of s squared plus 1 over s cubed. This is the very simple problem, but have a look on the formulas of inverse Laplace transformation. Is there any direct formula that is going with our given question?
No, sir.
No, actually it is s squared plus 1 over s cubed. But here we have a formula for inverse Laplace of c by s, inverse Laplace of this, inverse Laplace of 1 over s minus a, like all these things. But we don't have any direct formula that is going with our given question. But we have the property. The property is the linearity property. We can also use shifting property. Sometimes in order to solve the inverse Laplace transformation, we may have to use partial fraction. So these are the requirements we have to have previously. Okay, so here what we can do, we can just separate like this. This is simple algebra. You know that Laplace transformation of capital F S will give us a function in time variable. So the function that we have compared with this one, inverse Laplace transform of f of s. So that means here capital F s is s squared plus 1 over s cubed. If we apply inverse Laplace transformation, it is sure, it is a must that we will reach to a time variable function. Automatically s variable will be converted to time variable. So let's try to solve. Now we can easily see that this two parts can be simplified. So what will be the simplification? It will be 1 over 1 over s, right? And this is 1 over s cube. So now linearity property says us that since we have the summation terms, we can separate. See here, we have summation, so we can separately write the summation terms. So let's use the linearity property of inverse Laplace transformation. So from here, what we can write? Inverse Laplace transformation of 1 over s plus inverse Laplace transformation of 1 over s cube. Now, we have total two problems here, the first problem and the second one. Now, let's recall the formulas. The formulas of inverse Laplace transformation are here. So inverse Laplace of c by s, constant by s is constant. So have a look. Inverse Laplace of constant by s is constant. Inverse Laplace of 1 over s will be, what will be the result? It will
So
be
1.
1. Yeah. So the formulas can be written here for our betterment. Laplace transformation, inverse Laplace transformation of constant by s is constant. So using this formula, we can write inverse Laplace transform of 1 by s is 1. So first part is done. Plus, what if we have 1 over s cube? So since in the denominator we have power, s power something, so let's try to relate which formula can be applied. In the first formula, there is no power, s power 1 only. Second one, yeah, we have s power something, n plus 1. So it is likely to go with this formula, right?
Yes, sir.
So let's write down this one. Inverse Laplace of n factorial by s power n plus 1 is actually t power n. So why we have chosen this formula? Because here in denominator we have s power 3. So we can be sure that this formula can be applied. But the problem is, here you can see that we have s power n plus 1, but here we have 3, s power 3. So we need to compare the formula with this problem. We need to have the same format like the formula whatever we have. So let's try to make the same format, then we can directly apply. Try to understand, we have solved this one easily, but in order to solve the second one we have to think a little bit. Okay, so that's why let's try to figure out. So you can see from the formula that here we have s power n plus 1. So how can we write? We can write s power 3. 3 can be written as 2 plus 1. Is this okay?
Yes, sir.
Yes, sir.
But still now, have a look that in the formula we have s power n plus 1, and in the numerator, in the upper part, we have n factorial. So whatever value we have here n, that should be also in upper part with factorial. n factorial. So here, what is the value of n here? Try to look at
So 2.
2. So 2 should be here, right?
Yes, sir.
Yes,
But
sir.
we don't have to. So what we have to do? Can you guess? Otherwise, we will not get the solution. So this is the complicated part. Coming from the reverse position is difficult in inverse Laplace transformation. So try to understand. Here we have n as 2, and we are sure that that 2 should be here with factorial. We are applying the formula. So this equation and this equation are obviously not same, because here we have 1 and here we have 2 factorial. So how can these two equations will be same? It will be same if we take this, right? Then
Yes,
this
sir.
constant part and constant part are getting vanished, and we are getting 1. So have you understood?
Yes, sir.
Yes,
Okay.
sir.
So now it is easy to solve. Now it is going with the direct formula. So that means 1, this is 2 factorial, plus 1 over 2 factorial means 2. So now try to tell me the answer. Inverse Laplace transformation of, you know that inverse Laplace transformation of n factorial over s power n plus 1 will be t power n. So what will be the result here? It will be, try to think. Yeah, I'll try to provide the today's lecture video also. If you have any problem, you can ask me in chat also. Okay. So inverse Laplace of this one, what will be the result? Please try to tell. See the formula.
So t power 2.
T power 2. Thank you. So this is the result. So this is our final result. T squared by 2. So see, whatever problem we have, inverse Laplace transformation of f of s is f of t. Finally, we have reached to a function with time variable. So this is your final answer. So have you understood whatever I'm trying to say? Any problem here?
Yes, sir.
Any problem here?
No, sir.
No, sir.
So now I think you have the idea about inverse Laplace transformation. So let's move to the complicated problems. For your practice, I will suggest you, please try to go through 7.1, 7.2 and 7.3. At least the examples. The solutions are here, but you have to know how the author has solved the problems. Okay, so let's move to the complicated problems. Suppose we have inverse Laplace transformation of 1 over 2s negative 2s negative, let's say 7. Can we solve? Let's recall the formulas. So be sure whenever you are appearing for the exam, please keep the formulas with yourself. So here you can see that the problem that we have here, 1 over 2s negative 7. that is going with which formula? Try to check. In denominator we have s, constant s, n factorial, s power n plus 1, 1 over s minus a,
Third one is closed.
third. Yeah, so that means we are assuming that this formula can be applied. 1 over s negative a will be e power at. Inverse Laplace of 1 over s negative a is e power at. So have a look here. In the main formula, we have just s, not 2s. So what we have to do here, we have to rearrange the given question. So what we can do, we can take the factor 2 so that it looks like s minus a, right?
Yes, sir.
And Laplace transformation follows the linearity property, and in linearity property you have learned that both Laplace and inverse Laplace transformation pulls out the constant before. Suppose we have inverse Laplace of AFS, then we can pull out the constant before. So it will be A inverse Laplace of f of s. I am writing in shorthand. So here, what we can do, our constant term is 1 by 2. So let's bring 1 by 2 before the inverse Laplace operator. So we have 1 over s negative 7 by 2. So now let's have a look here. It is going with directly this one. Inverse Laplace of 1 over s negative a is e power at. So 1 over s negative a. So what is the value of a? It's 7 by 2. So the result is finally in our hand. It will be e power what? E power
Sir, A, 7 by 2.
7 by 2.
7 by 2 t, right?
Yes, sir.
So this is our result f of t. Done. So I hope you have understood this one. Let's solve some other problems. Suppose let's say we have inverse Laplace of 4 over s negative 2 negative. Okay, let me make it complicated. 4 over s negative 2 negative s over s squared negative 16 positive 4 over s squared negative 4 or positive 4, let's say. So we have to solve or evaluate this inverse Laplace transformation.
স্যার
So
এস স্কোয়ারের সাথে একটা কনস্ট্যান্ট নিয়ে করে দেখাবেন, লাইক এস স্কোয়ারের আগে একটা কনস্ট্যান্ট আছে এরকম।
before s squared.
জি স্যার।
Okay. Let's say we are using 2s squared. So at first sight, what we can do, we can write separately inverse Laplace of 4 over s negative 2 negative inverse Laplace of s over 2s squared negative 16 plus inverse Laplace of 4 over s squared plus 4. Have you understood how we have written this one? We
Yes,
have
sir.
written this one by using linearity property. So also the constant can be pulled out. So let me write directly. Constant is 4. So I have written directly. Here also we have constant 4. So let me write 4 before. It is 1. So now we are able to split up by using linearity property. Now we have total 3 problems. So what we can do? Step by step we can solve. So it is 4. Now inverse Laplace of 1 over s negative 2. That means 1 over s negative a will be e power at. So using this formula, we can write the result for the first one. E power, what will be the result? 2t, right?
2t. Yes.
Negative. This one is going to be the complicated part. So let's leave this one for now. We'll think about this one later. This one, third one. 4 inverse Laplace of 1 over s square plus 4. Okay.
So cos 40 হবে না?
It will be sine. Have a look here. Constant s squared plus k squared. That k should be here. So sine 4t. So that means inverse Laplace of 1 over. Try to understand the formula. The formula says that inverse Laplace of k over s squared plus k squared will be sine kt. Right?
Yes, sir.
So in denominator we have to use the same format. Since in upper part we have constant, so that's why we are sure that sine kt will be coming. But if in upper part we have s, we have the variable, then we'll get cos kt or cosine kt. So for this one we will get cosine. So here we can see 4. So 4 can be written just like this. It will be 2 squared. Is it okay?
Yes, sir.
Yes, sir.
Let's try to again solve or simplify this one. Already we have solved the first part, so no need to think about this. We have to think about the later part. So 4 e to the power 2t negative inverse Laplace of, have a look here. We have given one constant, so that's why things is getting complicated. So what you can do, have a look on the denominator. We have 2s squared negative 16, and in numerator we have s. So which formula can be applied? S over s squared negative k squared, right? Negative, have a look, it is negative. If it is positive, then we will get cosine kt, but if it is negative, then hyperbolic cosine kt is coming. Is that okay?
Yes, sir.
So the formula says that inverse Laplace of s over s squared negative k squared is hyperbolic cosine kt, cosine s kt. So you can see here we have in the main formula we have only s squared, not 2s squared. So what we can do, we can make it just like this. 2 can be factored out, so it will be s squared negative 8. Is it okay?
Yes, sir.
Yes, sir.
In upper part we have s. So plus 4. Let's have a look on this 1 over s square plus 2 square. It will be going with this formula, k over s square plus k square. But here we have the value of k is what? 2, right?
Yes, sir.
K should be in upper part,
Yes, sir.
isn't it?
Yes, sir.
So let's make it similar to the formula. So 2 s squared plus 2 squared. So which one is the extra part? We have to balance with the previous equation.
So 1 by 2 will be
So that's
multiplied.
we have given 1 by 2 previously. Is it okay?
Yes, sir.
Yes, sir.
So that 2 and 2 can be cancelled. So let's try to solve again. So 4 e to the power 2t negative. Now we can see that here we have 1 by 2. So 1 by 2 is constant. Let's bring out before. We have s over s squared negative 8 plus 4 by 2. If we simplify 4 by 2, it will be easier for us. It will be 2. So that means 2 inverse Laplace of 2 over s squared plus 2 squared. So 4 e to the power 2t negative 1 over 2 inverse Laplace of s over s squared. Have a look here. The formula says that inverse Laplace of s over s squared negative k squared. So here we have 8. Just to make it k squared form. So what we have to do here? Can anyone guess? It will be easy.
Into 2 square, sir.
Root 8 squared, right?
Yes,
Yes,
sir.
sir.
Yeah. So plus 2. And this is going with the direct formula. If we have inverse Laplace of k over s squared plus k squared, then the result will be sine kt. So now tell me what will be the result here? It will be sine what? 2t. Is it okay?
Yes, sir.
So finally, step by step, we are reaching to the final result. 1 over 2 inverse Laplace of s over s squared negative k squared. So here remember the value of k is root 8. So what will be the result? It will be hyperbolic cosine kt. So cosine s kt, that is root 8t. Clear?
Yes,
Yes,
sir.
sir.
Plus 2 sine 2t. So finally we are able to solve. This is our final result, which is the main function f of t. So we can verify. If we now try to apply Laplace transformation here, you will get easily this one, the main function. But whenever we are coming from inverse Laplace transformation, so we have to think a lot. We have to think about the properties, we have to think about the formulas, we have to relate the formulas, we have to make the formation also. Then only it is possible to get back to the main function. So that's why I always try to say that inverse Laplace transformation is little bit difficult, but the process of solving is fun. So have you understood?
Yes, sir.
Yes, sir.
So you know that The inverse Laplace transformation has two properties, linearity properties and the shifting properties. So up to now we have solved the linearity property problems with the help of the formulas. But now we are going to have a look on the property that is called shifting property of inverse Laplace transformation. That will be again difficult, but let's hope for the best. We can solve any problem if we have the basic idea. So let's recall the property that is called shifting or translation property for inverse Laplace transformation. So you might remember that if inverse Laplace transformation of f of s is small f of t, we don't have any doubt here. So what if we have inverse Laplace of f of s negative a is equal to, it will be e power at f of t, and the vice versa, that is the Laplace transformation is also same. So we have learned in last consultation, and now we are checking the inverse Laplace transformation property that is called the shifting or translation property. So using this concept, let's try to solve some problems. Suppose we have, let's say, inverse Laplace of 1 over s negative 2 squared plus 1, or let's say plus 4. So have a look on the formulas of inverse Laplace transformation. It is likely to be go with which one? Constant over s squared plus k squared will be sine kt. That means from our first observation, we can understand that we know inverse Laplace of k over s squared plus k squared can be written as sine kt. So this formula can be applied, but we are not sure up to now. Okay, but out of all these formulas, this formula is closely related to this one, because here we have something squared, s squared plus k squared. 2 can be written as 2 squared. Sorry, 4 can be written as 2 squared. Isn't so?
Yes, sir.
So here, the main problem that we have here, instead of s, we have s negative a, s negative 2. Okay, let me make it more complicated. Suppose we have s positive 2. So here we have s, but here we have s plus 2 whole squared. So something we need to reform. So what we have to do? So you know that in last consultation, whenever we are dealing with shifting or translation property for Laplace transformation, we have applied some steps. We have followed step 1, step 2 and step 3. Finally, we have found a solution. But now in inverse Laplace transformation, we can also solve this problem by following some steps. So let's say step 1. In step 1, we have to think about which formula can be applied and see the main property. Here we have S negative A. So we have to understand what is the value of A. That means find A by comparing with S negative A. That is the question. And in step 2, try to find f of s function, capital F s, not f of s minus a. Once you have f of s, find the inverse Laplace of f of s. It will be f of t. Step 3. So finally the answer of the main function will be this f of t with e power that a, whatever you have found previously, a t. So that will be your final answer. You will understand whatever I have mentioned here if we try to solve this problem. So you can understand that in step 1 we can understand this problem is going with this formula, but the problem is here we have s and here we have s plus 2, so that is definitely going with the shifting property. So that means here s, that means s can be replaced by s negative a. So s plus 2 compare with s negative a, we have to compare it will be s negative negative 2. So what is the value of a?
-2.
Minus 2. That is the thing. So comparing with s negative a, we have found a as negative 2. This is step 1. So step 1 is completed. Let's say step 2. In step 2, we have to find f of s by replacing s negative a by s. Try to understand because the steps have to be followed. So here whatever we have, inverse Laplace of 1 over s plus 2 squared plus 4. That means where we have s negative a, let's put s instead of s negative a and try to find f of s by replacing s negative. So the given problem, from the given problem we are writing just like that. Inverse Laplace of 1 over so s negative a, that means s plus 2 should be replaced by what? We should replace s plus 2 by s squared instead of s plus 2 plus 4. So whenever we have replaced s negative a by s, then we can easily find what is f of s. So what is our f of s? capital Fs, this one, right?
Yes, sir.
So now in step 2, you can see we have to find the inverse Laplace transformation of f of s. That will give us f of t. So let's try to find the inverse Laplace transformation of this one. Is it okay? Are you understanding?
Yes, sir.
So now inverse Laplace of 1 over s squared plus 4, that means 2 squared. S squared plus k squared, s squared plus 2 squared. So we know the formula. The formula says inverse Laplace of k over s squared plus k squared, that will be sine kt. So compare with this formula. Do we need to any rearrangement? What should we do here?
Sir, 2.
Yeah. Here we have k squared. That k should be here also. So that means we have to use 2. But just to balance this equation with the previous equation, we have to multiply 1 by 2. Then 2 and 2 cancelled, so we are getting the previous one. Is it okay?
Yes, sir.
So 1 by 2, now inverse Laplace of 2 by s squared plus 2 squared is sine 2t. That means step 2 is done. We have found f of t. So this is f of t. But don't forget that it is not our main result. We are trying to solve not this problem. Our target is to solve this one, having s plus 2 squared plus 4. So that's why I have written here step 3, that is the final answer will be e power at, whatever a you have found previously, e power at with the previous f of t that you have found in step 2. So that means the final answer will be e power at f of t. That means e power, what is a? A is minus 2, e power minus 2t, this f of t, 1 by 2 sine 2t. So this is the result for inverse Laplace of 1 over s positive 2 squared plus 4. So am I able to make you understand about the shifting property?
Yes, sir.
Yes, sir.
Isn't it hard?
No, sir.
So actually we have to understand the steps, then we can solve whatever we want. So you will understand if I show another problem that is also based on the second property, that is called the shifting property. So suppose we have, let's say, inverse Laplace of s plus 2 over s plus 2 squared negative 25. I hope we can see whatever I have written. So from here, we can see that inverse Laplace of s plus 2. See, in upper part we have s variable, s plus 2. In denominator, we have s plus 2 whole squared, negative 25. So let's try to think about which formula can be applied. S over s squared negative 25. S over s squared negative k squared. So this formula can be applied out of all the formulas. So here, let's write down the formula. We know that inverse Laplace of s over s squared negative k squared, that will be hyperbolic cosine kt. But what is the difference here? If we compare this problem with the formula, then we can easily understand that here we have s plus 2, but in the main formula we have s. So that is the difference. But we don't need to have any tension because we have the shifting property. Shifting property says that we can shift s plus 2 to s. So step 1. Let's write s plus 2. If we compare with s negative a, then we can say it will be s negative 2. We are maintaining negative sign, s negative 2. So what is the value of a? A
Minus
is minus 2. So this is okay, done. Now step 2. In step 2, let's replace s plus 2, that means s negative a by s. So where we have s plus 2, let's replace this one by s. That means the given problem is now being rearranged. Where we have s plus 2, we are replacing by s. So s squared negative 25. And now let's try to solve. That will be whatever result we will have, that will be f of t. And the inside quantity is our capital F s. So now we can write inverse Laplace of s over s squared negative 25. So here we have k squared 25, that means 5 squared. So finally the result will be hyperbolic cosine 5t. So is it okay?
Yes, sir.
Yes, sir.
And let's write down the final result. The result, what will be the result for the given question? So step 3. So in step 3, the final result will be e power at f of t. So e power a is minus 2t, f of t is this one, whatever we have found previously in step 2. So cosine a is 5t. That is your final result, the result of this part. So using shifting property, we can solve inverse Laplace transform. Done?
Yes,
Yes,
sir.
sir.
So by the time you have all the idea, whatever you need. But the problem is we have also one thing to know, that is sometimes the method of partial fraction can be helpful while evaluating the inverse Laplace transformation. So let's try to discuss what is partial fraction. By using partial fraction, we can solve inverse Laplace transformation. So up to this part, if you have the idea up to this part, then I can definitely say that you are ready to solve any problems from inverse Laplace transformation. So let's try to recall what is partial fraction. From your very childhood, you are working with partial fraction. In school level, this method has been taught. Okay, so partial fraction says us that there are three types actually, but advanced types can be taught based on the three types. So let me write the type 1. Suppose we have something over s negative a, s negative b. Then what we can write? We can write a over s negative a plus b over s negative b. We may have also s plus a, s plus b. The process is same. Can you remember all these things?
Yes, sir.
Yeah. We have type 2. No need to go through all the types, but somehow we need to know the basic concepts only. So something over s negative a, let's say s negative b whole squared. Whatever quantity we have in the parentheses, that are called factors. So s negative a is a factor with power 1. S negative b is a factor with power 2. So since s negative a with power 1, power 1, power 1, so it goes with type 1. So that means s negative a will come up with a constant. But s negative b whole squared, for this part, we have to decompose this function. All these things are called, these functions are called rational function, having p by q form, ps over qs form. Okay, so where the denominator is not equal to 0. So for s minus b whole squared, we have to come up with b, and then s minus b whole squared with another constant c. Suppose we have s negative b power 3, then it will be b over s negative b, c over s negative b squared plus d over s negative b cube. So that is the way how we can decompose. Type 3. Suppose we have something over s negative a with another factor s squared negative b. Let's say it will be quadratic form. It may be s squared plus bs plus c form also. So in that case, how we can separate, how we can decompose? Think about the first factor, s negative a. S negative a will come up with a constant because it is of power 1. So that's why it is called linear factor. s negative a with a plus for s squared negative b, we have to come up with bs plus c. So these are the types of partial fraction. I hope you have learned these three basic types from your previous math course.
Yes, sir.
Okay? So why do we need partial fraction here? Partial fraction is somehow helpful in solving inverse Laplace transformations. So let's say we have a problem. This will be the last problem for this session. So suppose we have to solve inverse Laplace of 3s plus 1 over s plus 1 s squared plus 1. So the problem is, in denominator we have total two factors, s plus 1 s squared plus 1. So there is no such formula given. You can see we have only one factor, s negative a, or we have only one part, s squared plus k squared, s squared negative k squared. It may be s squared negative k squared, but there is no multiplication term formulas type. Is there any?
No, sir.
No, sir.
So that means we can't apply the formulas, and also it is not going with the shifting property. We may think about the shifting property because we have s plus 1, so we can think about s negative negative 1. But what if we have here s squared plus 1? So shifting property is also not working. So in that case, the only method that can help us to solve this inverse Laplace transformation is the partial fraction decomposition. So now we have to think about which type is going with the given question. Type 1, 2, 3. Tell me.
So 3.
3.
So remember the constant that we have in the numerator, a, b, c, a, b, c. So we have to find these constants a, b, c, whatever, by plugging some values of s. We have to input some values of s so that we can easily find a, b, and c. So forget about the inverse Laplace operator. Let's bring out the function here. So here we have something 3s plus 1 over s plus 1 s squared plus 1. So it can be decomposed by s plus 1 with a plus s squared plus 1. So it is bs plus c. So the method of partial fraction says us that whatever term we have in left side denominator, this is left side, this is right side. Whatever term we have in left side denominator, that should be multiplied both in left side and right side terms. So let's multiply. So multiplying s plus 1 s squared plus 1 by, sorry, let's say this is equation 1. In 1, multiplying s plus 1 s squared plus 1 in equation 1. So what we will get if we multiply here? So this and this and this will be cancelled. We will get 3s plus 1 only. So 3s plus 1 in left side equal to a times. So s plus 1 will be cancelled, but we will have s squared plus 1 also, right? So it will be a times s squared plus 1. Do you understand?
Yes, sir.
And what will be here? It will be s plus 1. Is it okay?
Yes, sir.
So I am mentioning this with another equation, equation number 2, and this is equation number 1. So now we have to input in equation 2 some values of s so that we can get a, b, and c. So let's try to input. Let's say we are plugging s equal to -1, because if we input s equal to -1, so -1 plus 1 will be 0, 0 times something will be 0. Then it will be easy for getting a. So that's why we have chosen -1. So if you have confusions, if you have problems in dealing with partial fraction method, so you can have a look into the previous course Math 120, or you can have a look on my integral calculus playlist where I have discussed the insights of partial fraction. So I am going here in not in details, I am going quickly. So let's input s equals to -1 in equation 2. So from here we are getting, at first try to locate the s positions. Here we have s, 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 s. So 3 times -1 plus 1 equal to a times -1 squared plus 1. Do I need to show all the steps here, or can I write 0 directly?
So
Yes.
directly 0 लिख लिया.
Yeah, I think
Direct.
getting the idea what I am trying to say. So I am writing 0 directly because -1 plus 1 will be 0. So now we are getting -3 plus 1 equal to -1 squared will be 1, 1 plus 1 is 2. So 2 times a
Yes.
is 2. It is -2 equal to 2a. That means a equal to -1. That is done. And now similarly we have to find b and c. Let's plug some random values of s. So I'm using s equal to 0 in equation 2. So from equation 2 we are getting 3 times 0 plus 1 equal to a times 0 is squared, s is squared, 0 is squared, that means 0 plus 1 plus b times 0, that is 0 plus c times s plus 1, so that means 0 plus 1. So please try to have a look whether I have written the correct one or not. Try to verify. So 0 times 3, 0 plus 1 equal to a plus c times 1. So we are getting 1 a plus c. So already in previous step we have found the value of a. So 1 equal to a. A means -1. So plus c. So actually c equal to what? C will be 2, right?
Yes, sir.
So since we have A and C in our hand, so we can easily find B by inputting any number of S. So since we have taken S equal to -1 previously and S equal to 0, so then we can now take s equal to +1, or it is up to your choice, whatever you want to take. So now I'm trying to input s equal to 1 in equation 2. So 3 times 1 plus 1 a times s squared 1 plus 1 plus b times 1 plus c s plus 1, that is 1 plus 1. Please try to verify, otherwise it will be a problem. So 2a plus b plus c 2, so that means 4 equal to 2 times a plus 2 times b 2 times c. So now we have already a value, c value. So 4 equal to 2 times value of a is -1 plus 2b 2 times c.
2.
So c is 2. Thank you. So 4 equal to -2 plus 2b plus 4. 4 can be cancelled. 2 equal to 2b. So b equal to 1. Finally, we have found all the constant a, c, and b. So now have a look into this. This is our equation 1. So I am taking this one. So let's try to plug all the values of a, b, and c. So what is a? A is, can anyone tell please? It is -1, right?
Yes, sir, -1.
1 and c is 2. Thank you. A is -1 over s plus 1 plus, what is b? B is 1.
Yes, sir.
S plus c. C is 2.
2.
2 over s squared plus 1. So finally, we can write -1 over s plus 1 plus s plus 2 by s squared plus 1. So we are able to decompose this 3s plus 1 over s plus 1 s squared plus 1. But don't forget, our target is to solve the inverse Laplace transformation, right?
Yes, sir.
Yes, sir.
So let's apply inverse Laplace now. So since we know the linearity property, so we can separately write inverse Laplace term also. So is it okay?
Yes, sir.
So from this part we can write, so this is our given question in left side, and it will be equal to the right side if we can have the results in the right side, then that will be the result for the given question. So inverse Laplace, okay, since we have -1, so you know that -1 is constant, so let's pull out -1 before. So negative has been pulled out, so we have 1 over s plus 1 plus we have s plus 2 over s squared plus 1. Okay, I am keeping the same thing because here we have to think about some parts. So let's try to solve this problem. 1 over s plus 1. Try to have a look. Now we are ready to apply the formulas. Which formulas is going with? 1 over s negative a, right?
What one? Yes.
Yes, sir.
So negative inverse Laplace of 1 over, try to keep the negative sign because in our main formula we have negative. So just to keep the same format, it will be -1. So what is the value of a now? A is -1, right? So it will be negative e power a t. That means negative e power negative t. This is the solution for the first part. Is it clear?
Yes, sir.
Yes, sir.
So let's think about the second one. Here you can see that we have s plus 2 over s squared plus 1. In upper part we have s plus 2, but in lower part s squared plus 1. So 1 can be thought to be 1 squared. See, we have s squared plus k squared, s squared plus 1 squared, like that. But the problem is we have s squared plus k squared, s squared plus k squared with s and k. But whatever we have here, we have s and 2. Both s, both variable and constant are present. So we don't have any direct formula for this. So what we can do here? Can anyone guess? Anyone? You can remember that whenever we have started with Laplace transformation problem, the first problem, you can see we have started with this concept. Suppose we have s squared plus 1 by s cube. We can also simplify some parts so that we can get the main formulas to apply, right?
Yes, sir.
So we can also use this basic concept. So what we can do here, we can split up s over s squared plus 1 squared plus 2 over s squared plus 1 squared. And then, is there any problem if we
No,
separately
sir.
write this?
No,
No,
sir.
we can take the LCM. So these are the problems you may have in inverse Laplace transformation. You have to think a lot while solving a problem. So you can see that here we have 2. So 2 can be pulled out so that we have 1 here. So now inverse Laplace of s over s squared plus 1 squared, s over s squared plus k squared, 1 squared will be cosine 1t, right?
Yes, sir.
So cosine 1t, that means cosine t, plus 2 is here. Inverse Laplace of 1 over s squared plus 1 squared. This one, 1 over s squared plus 1 squared will be sine 1t. So sine 1t. That means finally the result is here. E power minus t cosine t plus 2 sine t. This is our result f of t. So inverse Laplace transformation, finally we can summarize this session by this general concept. Inverse Laplace transformation of any algebraic function will give us the main function that is in time variable back. So that's all from me. Thank you for joining the session.